Well, good morning, good afternoon, good evening, depending on where you're joining from or if you're catching the replay. And welcome to our first ZTNA Table Talks webinar of the year. I'm Mixa Gerard from the marketing team here at AppGate, and I'm happy to have you with us today to discuss Zero Trust Network Access. Before we dive in, just a few quick housekeeping items. This session is being recorded and you'll receive the replay within 24 hours. Feel free to drop your questions in the Q&A panel. If we don't get to them during this live discussion, we'll follow up afterward. You can also request translated captions from the menu panel. If you'd like to use that feature, just let us know so we can enable it for you. Now let's get into today's topic: secure and accelerate AI workloads. Maximize innovation while keeping your data safe with AppGate ZTNA. I'm thrilled to be joined by two fantastic speakers today: Michael Levy, SVP of Product Management here at AppGate, and Mark Hassey, Principal AI Engineer at AppGate. With that, let's get started. Michael and Mark, over to you.
Thanks so much, Ixta. Mark, you're a relatively new addition and have a very impressive team that you're leading at AppGate. You mind just giving everyone a little bit of a background and let them know what your team is doing at a high level?
Sure, Michael. Yeah, so I'm happy to have joined AppGate about 4 or 5 months ago. I'm a principal AI engineer here, leading the development of new AI-powered features. Prior to this, I was the chief engineer at the MITRE Center for Threat Informed Defense, where we help companies operationalize threat intelligence and adversary emulation. And prior to that, I worked at Microsoft on building isolated clouds for governments. Here at AppGate, we are building a new AI team. We're getting experienced engineers from Microsoft, from Harvard, working to build new AI-powered features, both to improve the existing AppGate product, but also to build new forms of agentic security in the future as well, which is kind of why we're here today.
Excellent, thank you. So I think I'm speaking to the right person. We're here to talk about agentic AI, and I feel like we are back in, I don't know, 2008. And I think something that's analogous to agentic AI is cloud computing. Back then when there was a lot more travel, pre-COVID, I think travel's picking up. Executives would fly through the airports, non-technical executives, and they'd see big shiny posters to move to the cloud. The cloud was a panacea that was going to fix everything. And then you had some pioneers rush over to the cloud. And then there was runaway cost, right? They moved workloads that have no business being in the cloud because there was fear of falling behind the competition in whatever industry you're in. And I feel like we're at a juncture that's similar to that. And I think what's important, just like the cloud kind of had an ambiguous definition, whether it was infrastructure as a service, software as a service, the parameters of what everyone was trying to sell was kind of blurry, right? Cloud was slapped on everything. And I feel like agentic AI or AI agents is overused. There really isn't discipline around what the definition is. For instance, I use ChatGPT agent mode, which I love, but it's not autonomous. So, could that really constitute agentic AI? So, given you live and breathe this stuff, let's level set on what we're talking about, what we mean here when it comes to agentic AI.
Yeah, I agree with you, Michael. I think we're in a hype cycle for sure. I'm watching football on the weekends and I'm seeing Matthew McConaughey hawking AI agents. I think that's how you know that we are really in the midst of a marketing driven cycle. But I also think it's important to understand that I think a lot of this is kind of there's a little bit of FOMO, right? People are seeing this excitement around it. They're seeing it on LinkedIn, seeing it on TV, and thinking like, "Oh, wow, are we falling behind? Do we need to rush and get this stuff deployed immediately so we can catch up?" And I don't think so. I don't think we need to be, overlooking cybersecurity or safety to roll out agentic AI. I do think it would be good to have a standard definition that we can use for the call today. And so the way I'm defining it for the purpose of this talk is agentic AI basically just means an LLM that has tools. And tools meaning the ability to reach out and touch things out in the world, like do web searches or look up product prices on Amazon or something. When you're just dealing with a chatbot like ChatGPT, it's just text in, text out. There's a kind of a limited realm of harms that can arise from that usage, right? Not a lot of cybersecurity harms involved in that chat scenario. But once that chatbot is connected to something, right? Like what if it can go out and buy things using your credit card? That's where we cross that threshold into, okay, now this is more kind of traditional cybersecurity concern around protecting data and making sure that the right people have access to it. And I also want to talk about how zero trust plays in here because I think it's a really good fit for this problem space. Zero trust is about having continuous and contextual authorization. So making sure that a person's access is based on their job role and their context, and making sure that people aren't over provisioned. They don't have access to too many resources. And so I think the same thing is kind of happening with agentic AI. There's a rush to connect these models to all these tools, but in the process of doing so, we're over provisioning them, right? We're giving them more tools than they need for the task at hand. And that's where that risk starts to arise.
All right, all right, all right, all right. I could tell you what I'm seeing. As any product leader ought to do. I speak to a lot of customers. I speak to a lot of enterprise directors of security, network security, CISOs. And look, I could get hyperbolic, and I mean this without fail. Every conversation I've had with large enterprise technical leaders, they've all told me something that is basically the same. It's consistent across the board. Their C-suite has created, and I've heard different words for it, a directive, a manifesto. It wasn't, rules and regulations. It wasn't guidelines. It's something that, connotes the ambition. Basically, what they're saying from the top to everybody in the company is go forth and be merry and experiment with agents anywhere and everywhere, because we are competing against peers who are doing this anyway, and we ought to do it too. And usually there's something about not siloing any data, kind of like what you said previously. And then there's a caveat, but please adhere to traditional security protocols, right? And this, you were talking about identities. These aren't people, these are machines. ZTNA is usually, from most vendors, predicated on a human identity and multi-factor authentication. So now you have non-human actors, and there isn't yet a standard machine identity protocol that's normative out there. So it's really hard to provide restrictive access to non-human actors. So, like I said, look, I'm the guy who cries Skynet. I've been wrong about this before, that I thought that, we're at that inflection point where everything is going to be terrible. I do have to say that the seemingly unconscientious experimentation going on everywhere is going to have some serious fallout. So, I think that the sky's going to be falling soon. I think we're going to see a major internal breach. I think we're going to see major exfiltration or deletion of data in a household name enterprise. Am I nuts? Am I wearing a tinfoil hat here? You're the technical expert. Where are we at this juncture with this, seemingly widespread and unchecked experimentation going on in almost every industry?
Yeah, I think you're hoping that I'm going to be the good cop to your bad cop, but I actually kind of agree with you. I think we are entering risky territory. Let's talk about the technology. These large language models are non-deterministic by design. That's the computer sciencey way of saying that we can't really predict what they're going to do exactly. Even with the same initial conditions, they're going to behave differently every single time we run them. It's also just a matter of fact right now that all of these models suffer from the same fundamental vulnerability, which is prompt injection, which means that as soon as the model is exposed to anything that's outside of kind of your trusted computing base, it can be influenced into taking inappropriate actions and doing things that are unsafe. And as long as that's true, this is a major risk that we're introducing when we rush to roll these out. And I do kind of agree with you in terms of seeing a high profile event. Throughout the cybersecurity industry, we've seen high profile events that sort of reshape or reprioritize the industry. There was the SolarWinds breach a few years ago, which kind of snapped everyone out of the lull of supply chain security and all of a sudden got people talking about it and thinking about it. I expect we'll see something like that in the agentic world, where all of a sudden we realize, well, actually, there are some pretty serious concerns around exposing these agents to malicious actors and also entrusting them to guard corporate secrets. I think we'll definitely look back on this period as probably overly optimistic.
Yeah, I think another thing analogous to the early days of cloud computing, there's shadow AI now. You could put out any sort of mandate with guardrails, and it doesn't necessarily mean that everyone's going to be a good steward and follow those controls that ought to be put in place. Now, I think that vendors ought to make it easy for there to be good corporate stewards who are trying to apply traditional controls. We have launched something that we can get to help companies, and we'll discuss that in a bit, to help users who are deploying these experimental agents apply traditional security measures over these autonomous or semi-autonomous actors. But I do have to say that the way that these, and I've seen some of these mandates are written, security really is an afterthought. It's not being enforced. It's saying, well, you ought to make conscientious moves, but I can tell you in practice, it does not seem like anything really is being enforced. So the rules are there and they're not being enforced. There's wild experimentation. I've been having weird dreams of, massive zero-day OT attacks. What is your team looking to build in the long term? I know we're in a very early inning when it comes to agentic AI security. What's on the roadmap to be able to help, create some calm amidst all this madness?
We are trying to figure out, what is the next step. We can take the existing sort of zero trust framework and apply that to AI, and that's something that I think you're going to come back to in a minute. But are also looking forward to what are the new challenges here, and what are some ideas to start addressing those. So I'll walk you through a few of those. One is what we call the agent process sandbox. So the idea is if you're running on an endpoint and you've got an agent running with you, so imagine like Claude Code or Claude Cowork, which just got released. Right now, our zero trust approach applies one set of policies to both of those things, both to the human using the laptop and the agent. And so what the process sandbox does is it allows you to run the agent in kind of like its own container, and then apply its own zero trust policy. So you could limit it to things that the human can see, but the model is not allowed to see. And so now you can start to kind of tailor security policy for that agent, which I think is pretty exciting. Some other ideas we're working on, we talked about the definition of agentic AI really meaning model plus tools. And I think the tool is really an ideal layer to be working on security because that's where the model interacts with the real world. And so we want to start looking at can we sort of audit and control which tools the agent is allowed to use, and enforce kind of like we do for zero trust with humans. This agent is allowed to use these tools under the following assumptions, right? Like it hasn't been compromised, it has its patches installed, keeping track of like is it using the tools responsibly? Is it accessing sensitive data and then sending an email? If so, that's a pattern that looks suspicious. So that's kind of one idea is starting to instrument the tool calls. And then finally instrumenting the LLM itself. So kind of looking at the token stream, the prompts, the responses. That kind of gives you insight into what the model is quote unquote thinking, right? Like, has it been steered into sort of malicious behavior by an adversary, or is it really staying on task and doing the work that it's supposed to do?
Interesting. One thing that really gives me a fright is machine to machine communication that, one agent will speak to another and convince an agent to access something it's not supposed to or exfiltrate information it's not supposed to. I see using LLMs right now, right? They have kind of when you send in prompts, there's certain controls that you could get around if you kind of social engineer the LLM to do things that it's not necessarily, supposed to do even within a private corporate environment, right? Is there anything any ideas that you have to be able to, well, one, I'd love to hear what you think about what would happen when it comes to the risk of machine to machine communication, and then, what you're going to be developing to help preclude that from becoming disastrous.
Yeah, as much hype as there is around agents, there's even more around this idea of like collections of agents all working together. This quickly gets into very dicey territory from a cybersecurity perspective. Imagine one agent has access to something or has knowledge of a secret API key or password. It can now like share that with other agents, or other agents might trick it into sharing it. And so, typically we try to sort of think about data governance and, who has access to what data and where it's moving. But with agents, those sorts of decisions and those guardrails we set up can disappear pretty quickly. I also just want to add that I think the sort of the approach the industry is taking right now is really kind of what we call the LLM guard, which is where you have one model that sort of acts like a gatekeeper and looks at all of the prompts and responses and tries to decide if another model is being compromised. But I'm
Mm.
sort of inherently suspicious of that approach. I think if you can compromise a model, then you can also compromise its guard. They're built using the same technology. That doesn't really make sense to me. Instead, I think the way that we govern those agent to agent communications is again looking at like tool calls and ultimately what work are they doing, and being able to trace through, this agent did something and then this agent did something else, and how do those two actions relate to each other? It's just starting with visibility, being able to see all of that, and then being able to layer policy on top of that in terms of what's allowed and what's normal. That's the direction that we're heading in.
Well, I hope we have those capabilities. Let's put the crystal ball away because I already have enough anxiety. I have enough anxiety about the future, or I have enough anxiety about today. Let's put away the future and talk about what someone could do today to minimize the threat landscape. So there are these mandates or manifestos, and even if there are employees within an enterprise that aren't supposed to do something and they are supposed to take certain measures, doesn't necessarily mean they're doing it, right? There's going to be shadow AI, and we've used this analogy: ashtrays on airplanes. Even though smoking has been not allowed on airplanes for several decades, even new jets are equipped with ashtrays because people are going to break the rules. So we have released something that I feel at this juncture allows everyone who's experimenting with agentic AI to be able to experiment in the most prudent fashion, right? As you mentioned, you could set guardrails around it, and people are deploying these agents everywhere. That's what customers are telling me. What enterprise users, they're deploying them in core execution venues. They're deploying it on client devices as well, like laptops, and wherever they're deployed there's a different risk profile. And the safest way to experiment would be putting singular agents on isolated execution venues like um, servers, bare metal servers, VMs, or Kubernetes clusters. And that's why we've released agentic AI security delivered by AppGate ZTNA, which will allow, given there is no consensus and normative way of um, delineating machine identity, using our headless client capabilities to be able to provide entitlements to AI agents so they only can access data that you would like them to. So applying zero trust principles to agentic AIs that are deployed in these safe havens. So do you agree that acting in that way is the most conscientious approach today? Is that what enterprises ought to be doing? Deploying these agents in these environments where you could, using technology like AppGate ZTNA's agentic AI core security, to be able to set conditional policies saying that this agent could only access this information repository given certain conditions, certain time of day, certain risk profiles. So do you think that, hits the mark in terms of, security for where we're at?
Yeah, absolutely. I think you're right. At this point, I think the goal is really to have the LLM in a sandbox. And so using existing network segmentation like the advanced connector that gives you that ability to control what the agent can connect out to. The agents are at a point now where they can just write their own code and execute it. And so that gives them a lot of flexibility, a lot of power to just reach out and touch anything in the network. And so just having that basic kind of zero trust framework put around it is a huge step in the right direction and makes that sort of experimentation a lot safer to do.
Mhm. Definitely. And we have this available today, and the way that we're working with our customers when it comes to this offering is suggesting us doing an architectural review and piloting it with one or two agents, and then having least privilege access for them, and then gradually providing more entitlements to give it more access to specific repositories of applications and of data and applications to be able to then see, because largely we don't know how these things will behave. So, this is, the most cautious approach to be able to do this experimentation right and to be able to innovate without concern. It seems that I've heard the term from many enterprise technology leaders. It's the wild, wild west over and over again. Unprompted, they've been saying that. And then I want to mention, in addition to what you're looking into, we are actively right now working on a agentic AI security at the process level. So when, and which is happening now, and I know for certain with Shadow AI that there are enterprise users who are deploying these agents on their own laptops, on their device. So the agent is basically inheriting the same access and permissions that the human user has. So what we're working on delivering in a few months is a technology that can differentiate between what the human's doing on a device and what the machine's doing. So you could restrict access specifically on the agent that's deployed on the user's device. So I feel between the course agentic AI security and the process level, we'll be able to, where the market is at, be able to offer the benefits of least privilege access and zero trust networking for the multiple execution venues and use cases where AI agents are deployed, which it seems like they're being deployed everywhere and anywhere. Um, so it's just the threat landscape just is really magnified because these agents are opening up access to different APIs and services, and the propensity for what could go wrong, and then the resulting financial damage and reputational damage is so incredibly severe that this needs to be reined in. and being able to control what these agents have access to will really, minimize the threat landscape. And what I believe is most attractive about this is that when applying zero trust network access, the applications that it does not have access to are cloaked. It's as if they don't exist. And, already working with LLMs, they will seek to achieve their directive, like any machine, no matter what. They will try to get past any barriers. So rendering applications that they ought to not have access to invisible, I think is the safest approach. So I believe, it's difficult to apply traditional security measures in this brave new world, but ZTNA, Zero Trust Network Access, seems to be one that is likely, the safest mechanism for secure access in doing that. Because we really need to treat these machines as if they're a human identity. Um, so I see we're nearing the half hour. Do we have any questions?
We do. Actually, we had one question come in. We're experimenting with autonomous AI agents internally. What are the biggest security blind spots you see organizations overlook when they first deploy agentic AI?
Mark, I'll let you take that one.
Yeah, that's a great question. I know we've covered a lot of ground here and it might feel overwhelming. One of the ideas I like that I think would really help focus your thinking about this question is this term called the lethal trifecta. This was coined by Simon Willison, who, if you're not familiar with him, very pragmatic advocate for LLMs. He does a lot of great technical writing on the topic, but he's also very kind of realistic about benefits and risks. So he coined the term the lethal trifecta, and it's got these 3 points. Does the agent have access to private data, like corporate data? Does it have the ability to communicate externally, like send emails or FTP servers? And does it have exposure to untrusted content? So those 3 things: private data, communicate externally, untrusted content. That's kind of the recipe for data loss, right? For example, if it can sign into Salesforce and then it has the ability to read emails and send emails, then an attacker could send an email influencing it to inappropriately go to Salesforce, get data, and email it back to your threat actor. And so I think that's a useful way of thinking about, what are real risks that we should be thinking about as we design these systems.
Thank you, Mark. There was another question that came in. How does ZTNA actually apply to non-human identities like AI agents or headless workloads? Is the enforcement model different from the traditional user-based ZTNA?
So for all intent and purposes, it's the same. It's about being able to deliver it. So given there isn't standardization yet, it is coming. It seems that there will be predominant methods of affirming machine identity. ZTNA will apply to agents leveraging machine identity just like it leverages human identity today. So as the industry matures, we most certainly will be able to do that. A proxy for kind of the moat of identity would be deploying these agents on isolated environments that we could leverage our headless technology for today, like an isolated server, a VM, or a Kubernetes cluster using sidecar injection. So essentially, a prudent user would deploy these. They ought to be doing anyway, given how experimental this is, in a safe environment, and then we can deploy this. We can deliver ZTNA with the same benefits, with the same conditional access that can be revoked if the risk profile gets higher. And we are actively working right now on a process level solution when the agent is deployed on the client's device. and not in the core, which most certainly is happening today. Both are happening. I can confirm that at most large enterprises, the experimentation is happening all over the place at all different execution venues.
Thank you, Michael. Here's another one. Lateral movement is a huge concern for us. How does your approach stop an AI agent or compromise API from pivoting across internal systems?
Mark, you want to take that one?
Yeah, and that's really why we see this as a zero trust problem because the same principles apply. If that agent has unrestricted access to the network, then you're absolutely right. And because they're typically running, in a trusted environment, they have access to all that internal attack surface area. The idea behind zero trust is let's really segment the network, only give that model access to the specific resources that we know it needs for its purpose. And so, basically just taking all the zero trust principles and just applying them to that agent.
Thank you, Mark. They're asking me here, what were the three things? Access to private data, access to email, and can read and send emails. What was the third one? Can you repeat that one?
Yeah, it was access to private data, the ability to communicate externally, and then exposure to untrusted content, as in like a way for a threat actor to influence the model. Think like prompt injection. I didn't come up with the term. I encourage you to go search lethal trifecta. It will come up much better write up than I can explain verbally here.
Thank you, Mark. Here's another one that came in. Do you see organizations relying too heavily on network segmentation alone to contain AI workloads? What's missing from that approach?
I can go first, Michael, if you want. I, yeah, I think it's a really interesting question, right? We've been talking throughout this entire discussion about applying the existing zero trust infrastructure to this problem. But I do agree with you is that uh, network level maybe is a little bit too high level to really see what models are doing. It may need, I used the example of Salesforce earlier. The model may have a legitimate reason to use Salesforce. We may want to be able to see what is it doing, which is why I was talking about our research into kind of the tool level of zero trust. If we can sort of figure out which tools, which is some jargon for really just like what is it doing on Salesforce? Is it reading data? Is it writing? Is it looking at contacts or is it looking at companies? Once we instrument that, then we can start to sort of govern it at that more fine-grained level and really get insight into what the model is actually doing.
Yeah, AppGate ZTNA collects a plethora of telemetry, which has a lot of insights you could extract from it. So, for instance, our application discovery feature identifies, who's accessing what. And if you were to use AppGate's core agentic AI security, and then leverage our application discovery feature, you'd be able to see what applications the agent is accessing. So, we're responding to our customers' voice and market demands. We're going to be building more when it comes to digital experience monitoring and observability because it's the need for knowing what's going on in the network and who or what is accessing what it's palpable, right? So that's what we're looking to do every day is take the treasure trove of telemetry that Zero Trust Network Access collects and give more transparency and visibility to network admins to be able to see exactly what's going on. And that will be able to, help identify exactly, how these agents are working in these experimentation phases and, how well they are operating within the guardrails that you're setting up.